Number 1, Unit 6, study guide. They want the formulas for the following. These need to be memorized for the SOL. These are not given to you. Inverse variation and joint variation. So direct variation is y equals kx. Inverse variation is y equals k divided by x. And joint variation is z equals k yx or kxy. Either way, it doesn't matter. These are the three formulas for direct, inverse, and joint variation. Okay, for number 2, to tell if a table shows direct variation or inverse variation, we want to look at these formulas up here. So I'm more interested in the inverse and the direct. And to tell what they are, we want to solve each formula for k. So if I go to the direct variation formula and I solve it for k, what does that give me? Draw a little arrow here. So if I solve it for k, it means I want to get k by itself. If I get k by itself, I divide both sides by x. So this is going to be y over x is equal to k. Now stop. I want to do the same thing down here with inverse variation. If I solve it out, what do I get? I want to solve for k, so I multiply both sides by, by x. And what does that give me? Yx equals k. This part right here, put a little red box around it. These are your directions for how to tell what happens with a table. And this gets a little confusing, so listen to what I'm saying again here. Y equals kx, that's direct variation. Y equals k over x, that's inverse variation. To tell whether a table is directly varying or inversely, you solve each one of these formulas out for k. So this one right here is the direct variation. This is the inverse. What does it tell you? Y divided by x. So if I look at table 2, let me scribble table 2 down here. What do we have? 1, 2, 3, 4, 5, 10, 15, 20. So this is number 2. I have two choices. If every y divided by every x gives me the same k value, it's direct. If every y times every x gives me the same value, it's inverse. So what happens in this table? Can I multiply every y times x and get the same number? 5 times 1 is 5. 10 times 2 is not 5, so that already throws that off, right? How about if we try the division one? Y divided by x. What's 5 divided by 1?
5.
What's 10 divided by 2? What's 15 divided by 3? 5. And 20 divided by 4?
5.
Okay, they all worked. Which one is y over x? It matches up with direct variation. So this table is a direct variation. Now, if I look at the one beside it, what do we have? 2, 3, 1, 9, 6. Okay, if I try the division rule again, y divided by x, what's 9 divided by 2? Nothing good, right? All right. How about I try multiplying the y with the x? 9 times 2? 6 times 3? 18 times 1? Which one of these rules, y times x, tells me I have a what? Inverse. So this table is inverse. Again, how did I find this? I took the original formulas. Direct variation is y equals kx, and I solve it for k. For the inverse variation, same thing. It's y equals k over x, and I solve it for k by multiplying both sides by x. They give me these formulas, and these formulas right here that are in the red box, call these your table tests. They're your table test. These formulas, when you solve them for k, it lets you test the table. So if every y divided by x works out to the same thing, it's direct. That was table 1 here. If every y times every x gives you the same thing, it's inverse. That's what we had over there. If you try both of them and nothing happens, example given that fourth table over there. So if you look at the fourth one, let me see if I can fit it in right here. The fourth one is what? 1, 7, 2, 9, 3, 12. That's enough. So does everyone multiplying give me the same thing? 7 times 1 is 7. 9 times 2 is not 7, so that doesn't work. Try dividing. 7 by 1 is 7. 9 by 2, not 7. 4.5, right? So that doesn't, so neither of them worked, right? So in this case, this would be neither. So these tables were either direct, they were inverse, or they were neither. Does that make sense? Yeah? Okay. Number 3, an asymptote is a line that your graph approaches, but it never touches. So before we look at number 4 and 5, let's recap. How do I find asymptotes? Let's make a list. To find the vertical asymptote. Remember there was all that math slang and jargon or whatever, but how did we write it? To find the vertical, somebody tell me, in English, how do you find the vertical asymptote? Zero out the bottom. So you have stuff, whatever, over the bottom. If I had x plus 2, my vertical asymptote would be at -2. How does that look on a graph? -2, vertical, and there it would go, right?
Wait, you got the opposite of that?
You zero it out, the opposite. So if it's x plus 2, think of it like this. If it's x plus 2, you set it equal to 0, subtract 2 from both sides. That's your vertical asymptote. Now, the horizontal asymptote. The horizontal asymptote is when we had those rules. What are the rules? We compare the degree, the exponents, right? I can have small over big. Small over big gives me 0. Here's an example of small over big. X over x squared plus 2. The degree up top is 1. The degree on the bottom is 2. This would give me a horizontal asymptote of 0. What's my next scenario? My degrees are equal. Right. So if they're equal, I get coefficient over coefficient. Example. Let's say I have 3x squared over 2x squared. My degrees are the same, so my horizontal asymptote would be 3 over 2.
Were you done with this? Can you please keep this up? Right.
Mm-hmm. Or just go back and watch the video. What else do we have? Big over small. Big over small results in what? None. Example. 3x squared over x. The degree up top is bigger than the degree on the bottom, at which case my horizontal asymptote is none. I don't have one. Now, there's one other exception to the rule. Remember when we had a number that was dangling outside? Example problem down here. If I say y equals 1 over, I don't know, x minus 2 plus 1. This number dangling outside here is your what? It's your horizontal. If there's a number that's dangling outside there, that is your horizontal. And then the number down here still, you zero it out, what would my vertical be? The vertical would be 2.
So what would you do with the horizontal?
So if I'd go to graph this, what would it look like? I'd have a horizontal at 1 and a vertical at 2.
So anything out there is your horizontal?
If that number's out there, that's your horizontal.
Oh.
Okay? So I'm going to keep the video going here. I'm not going to hit stop yet. Let's try an example for this. So let's say that I have, let's say I have y equals 1 over x minus 2. Is there a letter up top? No. So if there is no letter up top, there is no degree, meaning the degree is 0. So the degree up top is 0, and the degree on the bottom is 1, because the exponent here would be a 1, right? So I want to make my list. How do I find the vertical asymptote? I zero out the bottom. What does that give me? 2. I want to find the horizontal. The horizontal, I compare the degrees. The degree up top is 0. The one on the bottom is 1. So I have small over big, and because the degree up top is 0. There is no letter. If there is no letter, there is no degree. So it's 0 over 1, which is small over big, Is there an x up here?
I'm saying there's no letter.
If there is no letter, the degree is 0, right? So it's 0 over 1, and that's small over big, and small over big gives me a result of what? 0. So what is my horizontal? 0. And now, the one thing we didn't talk about yet, what is a hole?
A hole is what after you cancel what is left.
If you can cancel something on the top and bottom. Is there anything I can cancel here? No, so there is no hole.
I've got a question.
Slim,
If you did like,
speak loudly so this gets recorded.
if you put like 4 square, you have to square it, you're gonna make 16, or you count it and you just do square, 2 over 1.
If I put,
Instead of a letter, you put a number, but it's square.
oh, you wouldn't see a 4 squared. It would just be written as 16. You're not going to be given that. Now, something you might see, though, let's try another example down here. Let's say we have y equals x plus 2 over x squared minus 4. Anytime you can factor, you have to factor. Can I factor anything here? What can I factor, Joey? The bottom? Okay, speak up. They're not going to hear you on the recording. So this is y equals
x plus 2
2 over
I got you.
x plus 2, x minus 2. Now,
Then you cancel that.
first thing I do now is I want to make my list for the whole here because I should see something cancels. What's going to cancel? X plus 2. Now, to write the whole, you zero that out. So the whole is at x equals negative 2. Okay? I go to my vertical. The vertical asymptote, you zero out the bottom, but only whatever's left. So I already canceled this out for the whole. That's no longer a vertical asymptote. My vertical asymptote now is only going to be at x equals 2. And then I want to find the horizontal. Go back to the original problem to find the horizontal. The degree up top was 1. On the bottom was
1.
2.
Oh.
Right? 1 over 2. So that's small over big, and small over big gives me a result of,
Right, right.
small over big gives me a result of
0.
0. Got to memorize the rules. Remember the 3 rules there, right? Here. Small over big is 0. Equal over equal are the coefficients. Big over small is none. So I'm going to stop that. Okay, number 4. We're going to try to graph one of these. So we have the problem 4 over x minus 2 plus 1. This is a y equals. So let's make a graph over here. And what do I know? I want to find all the information. Are there any holes in the graph? Is there anything that's canceling? Any like quantities?
Nope.
No like quantities. I want to know if there's a vertical asymptote. Vertical asymptote is when I zero out the bottom, gives me a 2. Horizontal. Is there a number dangling out here? Remember we said if there's a number that's hanging out there, that's always the horizontal. Now, if there was not a number dangling out there, that's when you compare the degrees, right? You'd say, what's the degree up? And you go through your list. There is a number, so that's nice. Don't have to worry about it. So now let's illustrate what we have here. The vertical was at 2. Go to 2. Vertical means up and down. There's my vertical. The horizontal is at 1. And there we go. I want to make a table now. I want to make 2 of them. You want to make tables on either side of your vertical asymptote. So I'm going to make one over here, and I'll make one wherever, somewhere over here. What number is this? This number right here is a 2. I can't let x be 2, right? Because it's going to be undefined there. If x is 2, my bottom becomes 0, and this doesn't work. So I'm going to pick values that are greater than 2 and plug them in. What's the next biggest value I could plug in? I plug in a 3. What happens if I plug in 3? 3 minus 2 is 1. 4 over 1 is still 1. Or, excuse me, 4 over 1 is 4. And then 4 plus 1 is 5 is what I meant to say. All right, thank you.
Hold on. How'd you get that?
Let's go through it again. I didn't say that too well. Plug in the 3. 3 minus 2 is 1. 4 over 1 is still 4. And 4 plus 1 is 5. Let's plug in the next number. What else can I plug in? Let's plug in a 4. 4 minus 2 is 2. 4 over 2 is 2. And 2 plus 1 is 3. Let's do
How many
one.
do you have to do? How-
3 points would be
You know what
good.
I'm saying? Like when I'm on a test, how do I know when I have to stop?
3 points is good. We'll say you do 3 points. So what would be the next number? 5 kind of makes a mess. How about we do 6? Why does 5 make a mess? Because that gives you 4 over 3 and you get messed. You could do it, but try to make good numbers. If I pick a 6, I know that's going to be a 4 on the bottom, right? And 4 over 4 works, right? So
Plus 1 is
6 minus 2 is 4. 4 over 4 is 1, and 1 plus 1 is... So now I have these points, and if you start to sketch them, you're going to see you have a curve that looks something similar to that. Now, we need to do the same thing over here, but what is convenient about this? If I plug in -3, -4, and -6, I'm going to get the same numbers. Just what?
So now we have to do all numbers less than what?
No, I'm lying. I don't want the same numbers. Forget everything I just said about that.
You got 7%.
I want to plug in numbers to the left of 2. Okay, you could plug in those negative numbers, but those aren't the ones that you want to see.
So I can do 1 right. So 1.
You could plug in any number you want. Now, see what I did originally was I made -3, -4, -6. That's going to make it harder for you. The easy numbers are going to be the ones closer to this. What's the next number to the left of this asymptote 2?
1.
1. Let's plug in a 1. What happens if I plug in 1? Well,
You get a negative.
what's 1 minus 2?
1 minus 2.
1 minus 2 is what?
1, right?
-1. 1 minus 2 is -1.
Plus 1 is
So this
0.
is 4 over -1, so that's really -4. And -4 plus 1 is -3. So at 1, I'm at -3. What's the next number to the left? We could plug in 0. If I plug in 0, what's 0 minus 2?
0. No. 0 minus 2 is negative.
-2. So 4 over -2 is
Negative 2.
-2. And -2 plus 1.
Is negative 1.
All right. So you'll see that one is right there, and you're going to get your curve. Do a
Hey,
third
question.
point.
You have to graph all these, right?
Mm-hmm.
And then when you how you know how you do the curve thing?
I had this point here and that point there. You could you do your third point, it would land somewhere up here. These are inverse variation graphs. Remember we said these are called
Yeah.
branches? So you know it's going to be a curved graph.
How'd you get that one up there without? I don't see
This
any
one?
points. No,
I-
not that one. Other one up top. Keep going. No.
Up here?
That one right there. Yeah, that one. That's the banana.
I just sketched them very quickly. This is 3, comma, roughly 5. This is 4, comma, a little bit lower, 3.
But it has to stay within that graphic point.
Mm-hmm. The part I'm really interested in is that your table is right. Your graph doesn't have to be exceptional. I mean, if you plot these points on the graph, you'll see that it makes a little curved shape. If your table's correct and your graph is even, borderline coherent, you're going to get credit. The table shows me where you got all the math from. And then you just plot those points on the graph, and you'll see where they come from. Number 6. This is a review problem way back from earlier in Algebra 2. For absolute value, x minus 2 greater than or equal to 16. First thing I do is divide both sides by 4. Absolute value of x minus 2 is greater than or equal to 4. Absolute value means I get how many answers? 2 answers. So I say x minus 2 is greater than or equal to 4. And what's my other one? X minus 2. What do I do now?
You gotta-
Smaller or equal?
What do I do with that symbol?
You have to flip.
I flip the symbol. And what do I do with this 4?
Negative.
Make it negative. Good. So what do I do now? X is greater than or equal to 6. And x is less than or equal to
Well, you have to flip. What did you have to flip?
-2. When you're doing the absolute value, remember when I said -4, so it's negative, you flip the absolute value. Remember the absolute value rule, when you divide by a negative, you flip the symbol? How do I make a 4 into a -4? You technically divide it by a -1, right? So anytime you change that symbol, you flip the inequality. Okay? And then you go through and you solve, so you have 2 answers. That one and that one. And how do I put this on a number line? I'd say -2.
Oh, you gonna ask us to put it on a number?
I don't remember what the question on the test says. If it does, though, this is an or equals to, so it's a solid dot. Greater than goes that way. Also a solid dot. Less than goes that way.
The solid has got that little line.
Number 7, another review problem from last unit. 2x to the 3/2 power plus 2 is equal to 252. I want to get this x by itself, right? So the first thing I do is subtract 2. So 2x to the 3/2 power is equal to 250. I still want to get this x by itself. It's currently being multiplied by 2. So to undo a multiplication of 2, I divide by 2. x to the 3/2 is equal to 125.
No, you had to divide, you took away the 2 from the 2x?
Yeah, you divide
Divided
it,
by 2?
divided by 2.
Okay.
Now, here's where the tricky part comes in. What do we do to both sides? To get rid of that power, we raise both sides to the reciprocal power. So instead of 3 over 2, it's 2 over 3. Both sides to the 2 over 3. On the left, that becomes what? Power to a power is a multiplication. That's 6 over 6, which is 1, which goes away. X is equal to 125 to the 2/3 power. Now, we need to figure out what that means. Remember, power over root? Bottom one's the root, and the top one is the power. So what is the third root of 125? 5. And 5 to the second power is? There you go. There's your answer. Yeah, whenever you do these, little side note down here, x to the power over root. And which one do we always want to do first? Do the root first and then raise it to the next power. So example given, if you had x, let's say instead of x, let's say you had 16 to the 4, let's say the 3/4 power. This would be like saying the 4th root of 16, which is what? The 4th root of 16 would be what? 2, and then 2 to the 3rd power is 8.
Oh, so you do 3rd root or whatever it is to that power.
4th root of 16, and take that to the 3rd power.
So so when you did 125, the 3rd root was
5 squared,
and
20,
5 times 5 is
25. 11. Y varies directly with x. Stop. Don't even read it anymore. Write that out. Y varies means equals directly. Kx. So the first thing you need to do is write the formula, right? Y varies directly with x. We wrote the formula. If, you always write k. Remember, what's the direct variation formula? Y equals kx?
Direct variation.
Those are remember I said you have to memorize 3 formulas: direct, inverse, and joint variation. So it says directly is going to be y equals kx. If x is 10, stop, so plug that in. If x is 10, when what? Y is 2, what do I have left to find? K, so find that. So 2 is equal to, we don't say k10, it's really 10k. How do I solve that for k? Divide both sides by 10. Divide.
Wait, why do you got to divide to a 7? Because it's k?
Divide. Well, it's being multiplied, so to undo it, we divide. And then 2 over 10 is really what? 1/5. So 1/5 is equal to k. Now, is that the answer to my question? No. You need this to find the answer to your questions. We'll put some lines under it. But the question you're being asked is, find x when y is 12. So stop. We go back to the beginning. Write your formula. Y equals kx. What am I looking to find? Find x. Well, what do I know now? When y is 12, plug that in. What do I know about k now? K is what?
12?
It's in the problem.
1 over 5.
Wait, you see 12 in the problem.
It's right there.
Oh.
Second one. So y is 12. They tell you that. K, we figured it out, is what?
1/5.
1/5. And what am I looking for?
X.
X. So now I have this equation, algebra 1. 12 equals 1/5 x. Solve that by doing what to both sides? Multiplying by 5. Correct. So if I multiply both sides by 5, what do I get? 60 equals x. The answer to your problem is 60.
Hey, Mr. Baker, why did you multiply times 5?
How do you undo a fraction? Multiply by the reciprocal.
Oh, 5 over 1.
Side example in blue. If I told you this, 1/3 x equals 4. To undo that, I would multiply both sides by 3x equals 12. That's just an example, side example on how we solve that.
Okay, let's equal 60.
Okay, number 12. First off, you need to figure out, these problems will be on your test. Yeah, you need to figure out what kind of variation am I dealing with. It says it takes 6 people 2 hours to complete a project. How long would it take one person? Well, stop. Just ask yourself, pretend like you're building a house. If I started collecting people in this room to build a house, the more people I get to build my house, would it take more or less time?
Last time.
It would take less time. If I have fewer people working for me, it's going to take... So as one thing's going up, the other's going down, and vice versa. So what kind of variation do I have? Inverse. So as soon as you identify that, write the formula. Y equals k over x. Now the reason why this problem's hard is because they don't designate anything for you. They don't tell you what people are or what time is or what letter. They give you some, some for instances. So we need to make our own little designations here. And it doesn't matter in which way you do it. I'm going to say y is equal to people. You have to pick something and stick with it. Whatever you let y be, it's always going to be that. And if y is people, that means x is time. And now we're going to stick with that for the whole problem.
How do you on problems like how do you want to know that?
You can do it the other way around.
Yeah, you can do it.
Doesn't matter. Pick a way and stick with it. So if I know that, what do I know? I'm sorry, I'm looking at the wrong one. Take 6 people, right? So if y is people, I plug in 6 for y is equal to, I don't know what k is, but how long did it take those 6 people to do whatever they were doing? 2 hours. And what do I want to solve for? K. How do I do that? Multiply both sides by 2, so k is equal to 12. Again, that's not the answer to my question, just like in the last one, but it's the piece I need to find out. So I'm going to take this k is equal to 12. I go back to the beginning. Y equals k over x. Now what do I know?
You know 12, y is 6.
No, I keep going. Y is 1, because the question is, how long does it take one person to do the job? So now I want to know one person. So for people, I plug in 1. I don't know how long, right? That's what I'm trying to find out. So I let x be x. We're going to figure it out. What do I know k is, though, now? K is 12. How do I solve this? Cross multiply. 1x equals 12. Divide both sides by 1. That changes nothing. It would take him how long?
Wait, how do you do that?
12 hours. How do I do what math?
Cross multiply. How do you know you have to
Cross multiply. Anytime you go against an equal sign, you're cross multiplying.
So would it be 1 over 1?
Uh-huh. Now, that answer should make sense to you. If it takes 6 people 2 hours, how long does it take one person? Well, think about it. If I have 6 people, and so let's say I have this whole front row here, and then we leave Phil by himself. Where a second ago he had 6 people, but now it's just him. So if he had 6 people doing something, however long it took them, if he's doing it by himself, shouldn't it take 6 times longer?
Yeah.
Well, it was originally 2 hours for the 6 people, so if it takes him by himself 6 times longer, well, what's 6 times 2? 12. The answer should make sense. All right, for number 13, points of discontinuity. Points of discontinuity are what make the bottom 0. Okay, so I want to zero out the bottom. So for part A, I'm not writing them on paper, but you can listen. Part A, it would be what? 1. For part B, factor the bottom, plus or minus 3. For part C, no. Can I factor that? For part C, let's write it out.
Oh, because it's plus.
Part C, I have whatever, stuff over x squared plus 4. Is that the difference of... Can't factor that, right? So if you can't factor that, none, right? You can't do anything. There is no number that you could plug in to make that 0. So this one would be there are no points of discontinuity. D, factor that, and that would give you on the bottom
6 and 1.
x plus 6, x plus 1. Now, negative 6 and negative 1. Okay. Part E, you factor that. So again, you have stuff over,
Oh, you used it.
what do we get on the bottom? 2x and x. Put a 3 and a 2. Plus and plus.
Just break up the difference.
I'm sorry, you can't see it. Let me slide up. And you set these two to 0, right? So this one's going to be negative 3. This one over here would be negative 1.
Wait, where did you get that?
Zero them out. And the last one, part F. So we have x squared plus 1 over 3x squared minus 11x minus 4. All right, so we got to figure out how to factor this bottom. So what's going to go on the bottom? I'm going to say 3x and x. Would you agree? Okay, I'm trying to create a negative 11 in the middle, right? Whatever number I put right here, whatever number gets put right here is going to get multiplied by 3, right?
Yeah.
So how about we put a 4 there?
Yeah, so it's going to be 12 and plus 1.
So this is 12
Plus 1.
and 1 12 and 1 can get me to 11, right? What kind of 11 do I want? So I'm going to make this negative, so that's negative 12. And negative 12 plus 1 is my negative 11. Set these bottoms to 0. X is 4. X is negative 1/3. Subtract the 1, divide by 3. Kwame, is that good? What's that?
Can't see.
I mean, did you understand the math?
Yeah.
Okay, because you'll see it on the video.
Yeah, I might have been in the library and watched that.
Number 14. 30. X squared y to the 5th
This is number
over.
14.
This is number 14. 6x y to the 7th. All right, 30 over 6 is really what? 5. I have 2 x's up top. I have 1 on the bottom. Canceling leaves me what and where? 1 up top. Good. I have 5 y's up top and 7 on the bottom. 2 on the bottom.
Is this that? We would learn this.
This is all review.
Can you pull it up again?
You did 6 divided by 5? Is that how you got 5 inside?
30 divided by 6.
I mean, wait. Oh.
30 divided by 6.
Oh, all right. I don't make sure I was on the same page. That's a good thing. That makes me pay more attention and listen to myself.
Oh my.
Wait, but the x, the y to the x was the x squared.
I have 2 up top. I have 1 on the bottom.
So this will be y.
Well, we're not talking about the y's. So I have 2 x's up top
I mean,
and 1.
x. It's x.
So 1 x up top. And then 5 and 7, so 2.
You put the 7 outside?
7 is on the bottom. 5 is up top. So 5 over 7 leaves me 2 of them on the bottom. Okay, this is number 16. I already copied it down. When you multiply, you factor and cancel. So top left corner turns into what? X plus 1, x minus 1. Bottom left corner turns into x plus 2, x minus 2. Top right corner turns into x minus 2, x plus 1. Bottom right corner, not going anywhere.
Where's the line?
Now, you draw a line, connect the dots, draw a bridge. And now I cancel. What can I cancel? I see x minus 2 and an x minus 2,
Cancel those 2 out.
x plus 1 with an x plus 1. What are we left with? X plus 1, x minus 1, all over
X plus 2.
x plus 2. You are done. Division is the same exact thing, except what do you do to the second part?
Flip it.
You flip it and then multiply.
Wait, what about flipping?
If they ask for restrictions, restrictions are anything that make the bottom 0. So x could not be equal to what was on the bottom. This one right here would be a negative 2. This one here would be a positive 2. And this one over here would be a negative 1.
Hey, Mr. Baker,
Yes, Phil.
it wouldn't be right if you didn't do 17.
What?
You get the whole flip.
No, I get the what's the name we just did. But wait, oh my God, what's that?
What?
Oh no, what did you just write down
The
there?
restrictions?
Yeah. that
Anything that was ever on the bottom, you 0 it out.
Okay, so you have.
So this one would have been negative 2. This one's 2, just like points of discontinuity or vertical asymptotes.
No, Mr. Baker, I'm talking about that. No, I understand everything you did there. Except when you got the X and you got the equal sign with the slash through it and that.
Uh-huh.
Back to this one. And you have to get to make it 0. I'll be positive 2. So
We good?
you just go back to this one.
Oh,
Yep.
and those things count for everything at the bottom, though, right?
Right.
Yeah, those are the
All right.
Number 20. You want to find a common denominator. And to find a common denominator, you need to factor the bottom. Bottom left corner, 2 terms. Is it the difference of squares? No. Can I pull stuff out?
Yeah.
Yes. What can I pull out?
That's
2x. And what does that leave me?
plus
X plus 2. Remember you pulled a 2 out, right? So that 4 turns into a 2. So this is now gone. How about over here? Can I factor this out? Difference of squares, right? X plus 2, x minus 2. Now stop. What are all my different parts? I see a 2x, an x plus 2, and x minus 2. So we're going to say there's a left and the right. What's the left side missing? It's missing an x minus 2, so if I give it to the bottom, I also give it to the top. This one over here is missing a 2x. So I give it a 2x. So now let's do some math. On the left side, I distribute. 5 times x is 5x minus 10 minus, what is this really, 6x squared? All over, let's just put some quotes because we know what my denominator is. Okay, so what do we know? 5x minus 10 minus 6x squared. Be very careful of a double negative. If this 6x squared had been a negative, minus a negative would have turned it into a positive. That wasn't the case, so it's fine. We just subtracted it. And now this is all over stuff. Rate it in descending order. So, negative 6x squared plus 5x minus 10 all over. Now put my denominator. 2x, x plus 2, x minus 2. That is your answer. Remember, when you add and subtract, common denominator and then do the math. When you multiply, divide, factor, cancel. Okay, that's all we got. That's Unit 6. Test is Monday.